Hi. So here's another thing that I realized. Just me being the person who honestly wants to be the change that I want to see in society. I wanted to see more black girls in dresses, so I went out and I wore dresses. I also want to see just more black people in general get into technical careers. And so there are so many ways that you could do it. And I'm trying to document many of my own experiences and talk about them more vividly, just so more people can, I guess, self-actualize and see themselves doing it because they see me doing it. But obviously, a lot of people have heard of FANG. FANG is an acronym that stands for Facebook, Apple, Netflix, Google, but Microsoft it's not involved in the FANG acronym, but it's a huge company and they've been around for so long and they have something known as a technical blog. A lot of companies have technical blogs, but in my experience, when I've compared them, I personally have found the Microsoft technical blog to be like the most thorough. Their documentation is just really great. And a lot of people ask me about like the field that I am interested in specifically, and that's like reinforcement learning. So I've talked in the past about like other researchers in the fields, like who they are and, why I follow them and maybe, how I learned about them. And I guess I could make a lot more content about that. But I'm going to start today talking about the technical blog, and I'm going to read to you. This is like an intro blog post. So it's from the research collections, and it's just entitled Research Collection Reinforcement Learning at Microsoft. This was published December 7th, 2020. Now, I really like this research collection because it's time-stamped in a series. So it kind of like it starts from 2016 and then like works its way forward. And it highlights like different points in time, and like what was happening and why it's important. And I guess I also just realized that sometimes these technical blog posts can just be so overwhelming if you don't know, if you don't know what the thing is, you've never heard of it, you don't know how to apply it, you've never heard anyone talk about it, like all the context that you need in order for it to make sense, it doesn't, especially when it's not someone who you know and who looks like you. It's even more intimidating to get started. So here's what I'm gonna do. I'm gonna try to take some time, maybe not every night, but maybe every night. I mean, I don't actually have much else to do at this point since I'm cutting out my social life. That's another story. But yeah, so I can just we can read these blog posts together. And I mean, you can become at least as knowledgeable as me. Like this, I'm not even making any of this up. I'm just reading it right off the site. So there's research collections, reinforcement learning at Microsoft. Reinforcement learning is about agents taking information from the world and learning a policy for interacting with it so they perform better. If you think about like people in the real world and you're trying to figure out what are they talking about when they're saying agents, think of like a video game and the characters in the video game being like agents. It's kind of like that. Okay, so reinforcement learning is about agents taking information from the world and learning a policy for interacting with it so they perform better. So you can imagine a future where every time you type on the keyboard learns to understand you better. Or every time you interact with some website, it understands better what your preferences are, so the world just starts working better and better at interacting with people. And the person who wrote that is John Langford, who's a partner research manager at Microsoft Research in New York. Fundamentally, reinforcement learning is an approach to machine learning in which software agents interact with the environment receive rewards, and choose actions that will maximize those rewards. Research on reinforcement learning goes back many decades and is rooted in work in many different fields, including animal psychology, and some of its basic concepts were explored in the earliest research on artificial intelligence, such as Marvin Minsky's 1951 SNARK machine, which used an ancestor of modern reinforcement learning techniques to simulate a rat solving a maze. In the 1990s and 2000s, theoretical and practical work in reinforcement learning began to accelerate, leading to the rapid progress we see today. The theory behind reinforcement learning continues to advance, while its applications in real-world scenarios are leading to meaningful impact in many areas, from training autonomous systems to operate more safely and reliably in real-world environments, to making games more engaging and entertaining, to delivering more personalized information and experiences on the web. Below is a timeline of advances that researchers and their collaborators across Microsoft have made in reinforcement learning, along with key milestones in the field generally. Foundational work in reinforcement learning from 1992 to 2014. I mean, that's a very long period and not that many. This is interesting. So it says in 1992, this paper and its reinforced algorithm were instrumental in the development of policy optimization algorithms. This 1995 paper and the later journal version presented a novel approach to solving the multi-armed bandit problem without making any statistical assumptions about the distribution of payoffs. This 1998 paper and later journal version show how to learn optimal behavior in solving Markov decision processes generally. This 2002 paper showed the first conditions under which learning to improve a policy locally achieves optimal policies. In 2007, bandits that are generalized to use features in context are named contextual bandits. Also in 2007, the first public version of VowPal Wobbit is released, offering fast, efficient, and flexible online machine learning techniques, as well as other machine learning approaches. John Langford and several of his colleagues on this project later joined Microsoft Research to continue their work. Microsoft researcher John Langford presents a tutorial on interactive learning at the Neural Information Processing Systems Conference in 2013. In 2014, Richard Sutton and Andrew Bartow published Reinforcement Learning: An Introduction, recounting work in the field that began in the late 1970s. So some of these papers I hadn't heard of. I definitely know about the book Reinforcement Learning: An Introduction by Richard Sutton. That book is like the starting place for anyone getting started in reinforcement learning. I mean, maybe actually because the Microsoft blog is out now, this might be a better place to start, but the reinforcement learning book is definitely like a really useful place to start understanding reinforcement learning. Okay, so in 2016, work begins on Project Malmo. I'm familiar with Project Malmo because of what is the MineRL conference or competition. So the MineRL competition is a reinforcement learning competition that happens each year where you're trying to use agents to solve the Minecraft environment. And if you're able to, there's not prizes, but I think you get to present your paper at one of the like conferences. I think it's like NeurIPS and ICML. You get to present your paper at that conference, which in terms of like academic prestige actually looks really good. So that is really cool. Researchers at Microsoft Research Cambridge introduced the Malmo platform for artificial intelligence experimentation, Project Malmo, which uses Minecraft as a platform to help AI learn to make sense of complex environments, learn from others, interact with the world, learn transferable skills, and apply them to solve new problems. Okay. So there's a publication, the Malmo platform for artificial intelligence. Okay, and then you can download the actual package. 2017, Air Sim for Real World RL. Microsoft researchers begin work on the aerial informatics and robotics platform AirSim, an open source robotics simulation platform that designers can use to generate the massive datasets required to train ground vehicles, wheels robotics, aerial drones, and other devices without costly real-world field operations. Okay, so there's a podcast episode that explains this. Autonomous Systems, Aerial Robots, and Game of Drones with Gurdeep Paul and Dr. Ashish Kapoor, and a blog, Towards AI That Operates in the Real World. Hybrid Reward Architecture wins Mrs. Pac-Man. That's kind of cool. The Hybrid Reward Architecture project is established, combining standard reinforcement learning techniques with deep neural networks with the aim of outperforming humans in arcade learning environment ALE games. It achieves a perfect score on Mrs. Pac-Man. So there's a blog about that, a publication, and a podcast. In 2008, Bonsai, which is reinforcement learning for autonomous systems, Microsoft acquires a company, Bonsai, which developed a novel machine teaching approach based on reinforcement learning that abstracts its low-level mechanics. This enables subject matter experts to specify and train autonomous systems to accomplish tasks regardless of their AI experience. Now that's super interesting, and I feel like I have some other content about Bonsai, what Bonsai is and how cool it is, because the Bonsai team lives like one block away from me, so I think they're great. Teaching agents language decision making using games. Download Text World. Microsoft Research Montreal introduces Text World, an open source extensible engine that generates and simulates text games. This can be used to train reinforcement learning agents to learn skills such as language understanding and grounding, as well as sequential decision making. There's Text World, a learning environment for training reinforcement learning agents inspired by text-based games. There's another publication, Text World, a learning environment for text-based games. There's a blog, Project Malmo, Reinforcement Learning in a Complex World. So there's a little excerpt from the podcast. I'm going to read this out. I look at how artificial agents can learn to interact with complex environments, and I'm particularly excited about possibilities of those environments being ones where they interact with humans. So one area is, for example, in video games where AI agents that learn to interact intelligently could really enrich video games and create new types of experiences. For example, learn directly from their interactions with players, remember what kinds of interactions they've had, and be really more relatable and responsive to what is actually going on in the game and how they're interacting with the player. In 2019, Microsoft launches Azure Cognitive Services Personalizer. Microsoft researchers established the real-world reinforcement learning project with the goal of enabling the next generation of machine learning using interactive reinforcement-based approaches to solve real-world problems. One result of this work is the Azure Cognitive Services Personalizer, built on Microsoft Research's custom decision service and also supported by Val-Pal Wabbit. In addition to its availability to the developer community, and it is used by many teams at Microsoft, including Xbox, MSN, Microsoft.com, and the Experiences and Devices division. So there's a blog post about this, real world interactive learning at cusp of enabling new class of applications. Game of Drones competition. At NeurIPS, Microsoft researchers host the first Game of Drones competition, in which teams race a quadrotor drone in air sim to push the boundaries of building competitive autonomous systems. The competition focuses on trajectory planning and control, computer vision, and opponent drone avoidance. Project Padia established. Oh, I wonder, okay, I think this is still 2019. Yeah, it is. Microsoft Research Cambridge and game developer Ninja Theory established Project Paideia to drive state-of-the-art research in reinforcement learning aimed at novel applications in modern video games. Specifically, its early work focuses on creating agents that learn to collaborate with human players. Also in 2019. AirSim is released on the Unity platform. Microsoft holds its first MineRL competition on sample-efficient reinforcement learning, in which participants attempt to mine a diamond in Minecraft using only 4 days of training time. The top solutions are recounted in this 2020 paper. And there's a couple blog posts, 3 new reinforcement learning methods aim to improve AI in gaming and beyond. There's a podcast episode, Reinforcement Learning for the Real World, with Dr. John Langford and Rafa Hassan. A webinar and 2 videos, that's really cool. Okay, so then something is happening in 2020. At Microsoft Build, the company makes Project Bonsai available for public preview and introduces the Moab robotics platform for developers to test its capabilities. There's a paper that came out in 2020, a podcast episode, and the second MineRL competition. Actually, okay, this blog post is the blog post that I feel like I was actually going to start with. It's the NeurIPS 2020 Moving Toward Real World Reinforcement Learning via Batch RL Strategic Exploration and Representation Learning. So I think I'm gonna actually read this one next, but I just want to finish this one out. So here's the last event that's really cool. So in 2021, Microsoft will host its 3rd Reinforcement Learning Day event in January of 2021. This virtual workshop will feature talks by a number of outstanding speakers whose research covers a broad swath of the topic, from statistics to neuroscience, from computer science to control. The key objective is to bring together the research communities of all these areas to learn from each other and build on the latest knowledge. So this is really great, and the cool thing about this, it's not even just a blog post, it's like this aggregate of a ton of other blog posts and data set, like a literal research collection of all of these different things that have happened, and like, you know, how they make sense, and what, you know, like a snapshot of each year where we were in terms of reinforcement learning, which I think is just so cool. And I'm going, so I was reading over the blog post that I'm gonna, you know, I'll share in the next video. I was reading this earlier today, and there was a quote that I read that I thought was really great, and I wanted to unpack that a bit more, and I think I will do that in the next blog post. So we're gonna stop this one, but I hope this helps. I know that was like, I just literally just read the blog post out loud. But I feel like I'm trying to introduce other people, especially other, hopefully, young girls who look like me, other young Black girls who are just members of the community, who have an interest in computer science or possibly being a researcher, to what it actually looks like to be a researcher, how to participate in the community, what it means. Like, let's try to unpack the process a bit more. Yeah, cool.